Introduction to Data Lake. Hello, everyone. Welcome to Introduction to Data Lake. So, in this lecture, we're going to focus on understanding what exactly a data lake is and why it matters in our data-driven world and the various topics we're going to cover in detail. So, whether you are going to be a data engineer, business analyst, or just simply curious about the concept of data lakes, I believe after this lecture, you will have some insights and a solid foundation. Let's first define what a data lake is in simple terms. Then we're going to compare it to more traditional systems such as data warehouses and examine how and why data lakes have gained importance. And then we're going to look into architecture, best practices, governance, and security aspects. Traditional data management approaches. In order to understand why data lakes are important and transformative, it is important to step back and look at traditional database data management solutions. First, we have relational databases, or it's called RDBMS, which store structured data in a systematic way. Relational databases are great for transactional use cases where data is well defined and predictable. You can think of banking systems or enterprise resource planning and other operational systems for this case. After relational data warehouse came, and data warehouse has an environment designed specifically for complex analysis and reporting. And data warehouses typically employ schema on write. What does that mean? It means the structure or and schema of data are carefully defined and enforced at the time of ingestion. However, these two approaches can be limiting in a world where data is no longer strictly structured and big data volumes are growing exponentially. And thus, they can be expensive to scale, and integrating unstructured or semi-structured data, such as log files, social media feeds, or IoT sensor data, these unstructured, semi-structured data can become cumbersome. So there is that need for a more flexible, scalable solution, uh, which gave rise to the concept of the data lake. Moving on, what is a data lake? A data lake is a centralized repository that allows you to store all your not only structured data, but also semi and unstructured data at any scale. The keyword here is all. A data lake does not discriminate based on format, structure, or purpose. That means, unlike a data warehouse, uh, where you define the data model before loading, data lakes typically follow a schema on read approach. And what does that mean? It means schema on read implies that data is stored as is without requiring any predefined schema at the point of ingestion. When you actually retrieve the data for processing or analysis, that's when you apply the structure. And this flexibility is invaluable when dealing with large data sets of varying formats. And these formats can be text, images, logs, IoT feeds, and more. Additionally, data lakes are also known for being highly scalable and cost-effective, often built on cloud-based object storage platforms like Amazon S3 or Azure Data Lake Storage. And this has pay-as-you-go model and also has the ability to separate storage from compute cost, and these can be a significant advantage over traditional system. Data lake versus data warehouse. Um, if we are to compare data lakes with data warehouses directly, uh, you can first compare a storage format. Data warehouses enforce a schema on write policy, and this means data must fit a predefined structure before it's allowed in, and this ensures cleanliness but reduces flexibility. Data lakes use schema on read, and this means data is stored in raw form and only structured when it's accessed for analysis. And data warehouses and data lakes, they differ in data type and volume. So data warehouses are often optimized for structured data and predictable analytics workloads. However, data lakes can handle a wide variety of data formats as well as massive volumes. Uh, th- Thus, data lakes are more suitable for big data scenarios. Cost and scalability considerations. Data warehouses can become expensive to scale as they grow, uh, given the specialized hardware or appliance-based architecture. Data lakes, on the other hand, leverage low-cost object storage and can separate compute resources from storage, uh, making it more cost-friendly at scale. And they differ in ideal use cases. And data warehouses excel at delivering robust business intelligence, dashboards, and structured reporting. On the other hand, data lakes are often the go-to choice for machine learning, advanced analytics, and data exploration due to the flexibility they cover. So if you actually look at many organizations in practice, they choose to maintain both. And by maintaining both, they're using a lake house architecture or a complementary approach. And the key is to align the right repository with the right workload. Moving on, data lake architecture. So let's see how a data lake is structured architecturally. Although different organizations may implement it in different ways, most data lakes include the following core elements. Uh, Storage layer. So this storage layer could be on premises using technologies like Hadoop distributed file systems, or in the cloud using services like Amazon S3, Google Cloud Storage, or Azure Data Lake Storage. And the storage layer is typically designed for high durability and scalability. After storage layer, we have ingestion layer. So data lakes usually ingest data in various ways. Uh, Data lakes can be ingesting data from batch processing. What we mean by batch processing is when you have like daily or hourly data loads from databases, or data lakes can ingest data using real-time ingestion streams or near real-time ingestion streams from systems like Apache Kafka. And this layer uh, ensures that data from different sources is collected and stored in the raw zone of the lake. Next is catalog and metadata management. So in order to effectively manage data, it is critical to have a data catalog that keeps track of metadata. Uh, so it was like data schemas, data lineage, data quality, and ownership. And many modern data lakes incorporate metadata services like AWS Glue, Apache High Metastore, or proprietary solutions to make data discoverable and understandable. Lastly, is processing and analytics engine. So you will need to have compute engines that transform, analyze, or query the data. And for data lake, common tools include Apache Spark, Presto, or cloud native analytic services. And machine learning frameworks or advanced analytics may plug into the data lake to conduct more sophisticated data exploration. And when all these layers that we talked about work harmoniously, organizations can not only effectively store, but discover, process, and analyze large data sets without strict format limitations that data for previous data warehouses or relational databases had. Moving on to data ingestion and processing, uh, since data lakes can store both structured and unstructured data, the ingestion methods also have to be as flexible. If we first talk about ingestion tools, uh, Apache Kafka is one of the most popular tool for real-time streaming data ingestion, particularly for log data or sensor data from IoT devices. However, if you're looking at batch ingestion, tools like Apache Flume or Apache NiFi or custom scripts uh, can be used to pull data from source systems into the data lake. So we talked about Apache Kafka for real-time streaming data ingestion and Apache Flume or NiFi for batch ingestion. Let's talk about these two types of ingestion, batch and streaming ingestion. So batch ingestion involves scheduled data loading in large chunks, and this can be done nightly or monthly, hourly. And this is suitable for regularly updated transactional databases. On the other hand, streaming ingestion is continuous and near real time, and this ingestion is essential for use cases like fraud detection or dynamic pricing. And let's compare ETL and ELT approach. So traditionally, data was extracted first, then transformed, and then loaded. Thus, stand, thus it's ETL into a data warehouse. And the importance is that transformation took place before loading. However, in a data lake scenario, you might use an ELT approach, which means extract, load, and transform. So unlike ETL, data is first loaded in its raw form, then transformed later when needed for analysis. Last, let's talk about processing frameworks. Once data is in the lake, tools like Apache Spark, AWS Glue, or Azure Data Factory can be used to process it. Spark in particular is popular for distributed data processing and analytics due to its speed and scalability. The choice of ingestion method and processing framework depends on the nature of the data and the analytics requirements of your organization. Moving on to data governance and security. So we talked about data lakes and how data lakes offer flexibility. However, this flexibility can quickly cause disorganized data swamp if not managed properly. And this is where data governance and security come into play. So we're gonna first talk about the importance of metadata and cataloging. So in order to maintain order, it is really important to document data sources, data formats, owners, and usage policies. So a well-structured data catalog helps analysts and data scientists to easily find and understand the data. Second is access controls and identity and access management, IAM. It is important to define clear policies regarding who can read, write, or modify data in the lake. And uh, tools like AWS Identity and Access Management or Azure Role-Based Access Control are used to maintain uh, strict permissions. Third, data quality and lineage. It is important to ensure that processes are in place to validate data quality. Uh, Storing garbage data or data that can't be trusted diminishes the lake's value. Also, it's important to understand where data comes from and what transformations occurred and when in order to ensure auditability and trust of the data. Lastly, uh, regulatory compliance. This is important because many industries are governed by strict compliance regulation, such as GDPR if you're in Europe, or if your users are in Europe, HIPAA if you are in a healthcare industry, or FINRA if you're uh, dealing with financial institutions. Uh, so you want to make sure that your data lake implementation respects data privacy and security standards. And when governed properly, a data lake can serve as a reliable single source of truth for both historical and real-time data. Best practices and common pitfalls. So implementing a data lake is not as simple as just dumping all your data into one giant repository. So let's take a look at some best practices and pitfalls. First one is developing a clear business use case. You just don't want to build a data lake simply because it is trendy or because your competitors are doing it. it is really, really important to identify the exact questions and challenges your organization is trying to address. So knowing your goals helps you shape the data architecture, tools, and governance requirements. Second is implement robust data governance. As we discussed in the previous slide, without governance, a data lake can quickly become a data swamp, which means uh, it is untrustworthy, disorganized, and underutilized. Definitely spend time upfront defining governance rules, processes, and responsibilities. Third, organize data zones. Uh, Many organizations structure their data lake into distinct zones. Uh, Raw for the untouched data, curated for data that has gone through some level of cleansing, and sandbox for experimentation. And this approach helps you compartmentalize data based on its stage of readiness. Last, avoid the data swamp syndrome. The biggest pitfall is lack of control. So a sudden influx of poorly documented data uh, can disrupt analytics if data quality and ownership are not well defined. Regular audits, data catalogs, and collaborative governance processes go a long way in preventing this. So sticking to these best practices ensures that your data lake remains a, an asset rather than a liability. Use cases of data lakes. So data lakes unlock lots of possibilities across different industries and use cases. Uh, in this slide, let's take a look at some common scenarios. First is advanced analytics and machine learning. Uh, if organizations have data lakes, they can leverage data lakes to conduct complex data science experiments. And because data is stored in its raw form, machine learning models can be trained on massive amounts of diverse data sets. Second is IoT data handling. So these IoT or Internet of Things devices generate continuous streams of sensor data, and a data lake can store this real-time or near real-time data cost effectively, enabling predictive maintenance, anomaly detection, and more. And third is customer 360 and personalization. Um, Combining data from, say, various customer touchpoints, such as customer resource management system like CRM systems, social media interactions, transaction logs, helps build a 360-degree customer view. So using this, marketers and sales teams can then personalize user experiences. Last example is fraud detection and risk analysis. By analyzing large data sets from multiple sources, financial institutions can implement more efficient fraud detection algorithms and risk scoring models. So we saw that data lakes are versatile, making them a core component of data-driven strategies uh, in not only in tech, but also finance, healthcare, and beyond. Tools and technologies for data lakes. Uh, let's identify some of the major players in this area. So in terms of cloud providers, uh, AWS, Azure, and Google Cloud Platform. Those three are big players. And in AWS, S3 it can be used for storage, and Glue can be used for cataloging, and EMR can be used for processing. And in Microsoft Azure, Azure Data Lakes can be used for storage, and Databricks can be used for analytics. And in Google Cloud Platform, Google Cloud storage can be used, and BigQuery can be used for analytics. Hadoop ecosystem is also popular uh, if you especially have on-premise or hybrid setup. So Hadoop distributed file system can serve as the foundational storage layer. Then Hive can provide a metadata store allowing SQL-like queries on data in Hadoop distributed file system. For data processing engines, Apache Spark is widely used for both batch and streaming data processing, and Presto or Trino, these excel at interactive querying. Metadata and catalog tools, AWS Glue, what they do is they automatically crawl data in Amazon S3 to create a metadata catalog. Apache Atlas can be integrated to manage governance and metadata in Hadoop or hybrid environment. And the choice of technology usually comes down to existing infrastructure as well as preference for open source versus proprietary solutions and the level of expertise within the organization. Conclusion. So we covered a lot of ground today. Let's briefly recap the key points. A data lake is a highly flexible repository that can store not only structured data, but also semi-structured and unstructured data in its native format. And data lake enables schema on read, which allows for uh, agility in analytics and advanced use cases like machine learning. And we looked at data governance, metadata management, and security, and they are crucial to prevent a data lake from becoming a data swamp. And we also looked at some of the uh, popular tools and technologies in this space. Thank you everyone for listening.